Hi, my name is Carlos Tejeda, and what we're looking at here today are 8 BW monitor screens. What we're running remotely here are 8 boards in a TeraBox system. The boards are XUPVV4s. The purpose of this is to run all 8 boards with what we call our power glob load, and what it really does is just stresses the board's power supplies. In this case, what we're doing is trying to stress the supplies as high as we can and see if the liquid cooling works well on keeping the FPGA cool. So what you're looking at here is our BMC functionality on our boards, which they all have. What it does is, as you can see, allows you to monitor temperature, power on many different supplies and components. It also monitors, obviously, all the temperature and power, so that if the board exceeds a certain threshold, the board will shut down to prevent any damage. And these are live readings that you're looking at here, so you'll see them toggle slightly throughout the video. Power on these boards is about 229 watts total. Of the 229 watts, in this case, we're pulling about 134-ish amps of current on the FPGA, running at 0.85 volts core voltage. And as you can see here, throughout all the temperatures, the FPGA core temperature itself is at 50 degrees C. With the FPGA drawing 134 amps, the FPGAs are staying fairly cool. This is the beginning of our testing. The next boards that we have set up are going to be the 300 amp XUPVVP. The crypto version of these are going to be the CVP13 boards. Those have liquid cooling on the FPGAs as well as on the power supplies. So if you're looking here at our BW monitor BMC interface, you can see of all these temperatures, the power supplies are going to eventually be the limiting factor. With the slave supplies, mostly slave supply temp 1 usually is the highest, so it's about 104 degrees right now. I think the max on that is about 120 C. So what we're trying to accomplish with the liquid cooling on the XUPVVP, not just the FPGA, but on the power supplies, is that we don't have that limiting factor on the power supplies themselves. So as I mentioned in the beginning of this video, these are 8 boards running in a TeraBox system. So I think the best thing to do is to now go downstairs and we can go look and see this system in action right now with the liquid cooling. Okay, well now we're down here in the lab, as I had mentioned, and we're here with in front of the TeraBox system with the 8 XUPVV4 liquid cooled boards. There was a theoretical rise of about 3 C of temperature, the liquid from board to board. So rather than having 8 boards in series and have 24 C rise roughly from the first to the last board, we ended up doing 2 different loops of 4 boards. So the way it's set up here is you've got one output split to 2, and as you can see, these 2 are then sent into 2 groups of 4. Those loop back and forth between each boards, and then they exhaust back out to tubes out to the CDU unit, and it goes back around in a circle. Pretty good cooling. I think I saw maybe a 1 degree rise, if that, but all the boards pretty much were the same. So normally when you order a TeraBox system from BittWare, it's fully integrated, fully tested, and all cleaned up. This is a special case where we're doing some kind of research and development here for the liquid cooling. But in a full system without the liquid cooling, you would have all the wiring, all the baffling, all done and delivered. You would essentially get a TeraBox system with no wires sticking out, and everything's completely, fully validated. Okay, so let's get into some more details on the server and boards themselves. So as I mentioned, in here we have the XUPVV4. One of the features of the XUPVV4 is we have 2 UltraPort SlimSAS connectors per board. Those interfaces can be used to interconnect boards, and you can actually set them up in a daisy chain. Each
SlimSAS interface has 8 SerDes lanes on it, so you can have a total of 16 SerDes lanes on each board. You also have the 4 QSFPs at the front of the board, so theoretically you could have 400 gigabits per second in and 400 gigabits per second out of each board, daisy chained to each other. So you have a very high amount of throughput between boards if you needed it. Another feature here is the USB interface on each board. It's a USB micro interface. That allows you for communication to the board via the BMC, as I showed upstairs. It also allows you for USB to JTAG. And here we have all 8 boards connected through USB to a hub, a USB hub. And then through the system, we can access the boards via JTAG, each board, or through the BMC itself. So again, this is our TeraBox system. This is just one of a few that we offer. So in this TeraBox, we've got dual Xeon processors, scalable for your configuration. They're server grade, as well as the memory itself. This server itself can hold up to 24 2.5-inch drives, SSD drives, or mechanical drives. We've got another version that can hold up to 10 boards, where this one is 8 boards, and provides power and cooling for all the boards. If you have any more questions or if you need any more information, feel free to visit our website for information on the TeraBox systems or the XUPVV4s.